Here are some paradoxes that keep scientists awake at night. The universe is vast and complex, full of mysteries that have kept philosophers and scientists pondering for centuries. Some of these mysteries take the form of paradoxes, which are seemingly self-contradictory statements that, when examined closely, reveal deeper truths or highlight the limits of our understanding. In this video, we'll explore 3 paradoxes that not only baffled great minds of the past, but continue to haunt scientists in the present, keeping them up at night. So sit back, grab a cup of tea, or maybe a stiff drink if it's late, and let's delve into these thought experiments that defy logic and challenge our perception of reality. Number 3. Fermi Paradox. In 1950, Italian physicist Enrico Fermi was having lunch with a group of colleagues, including Nobel laureates like Edward Teller and Emilio, discussing the possibility of extraterrestrial life. Someone mentioned that there must be billions of Earth-like planets out there, and surely some of them must be inhabited by intelligent life. But where are they? This simple question became the starting point of what is now known as Fermi's paradox, a contradiction between the high probability of extraterrestrial life existing and the fact that we haven't found any yet. To understand this paradox, consider our own solar system. As mentioned earlier, scientists believe that there could be billions of Earth-like planets out there, each capable of supporting life. If this is true, then the Milky Way galaxy should be teeming with civilizations more advanced than ours. So why haven't we made contact with them yet? Why is the galaxy so silent? This apparent contradiction between the high probability of extraterrestrial life and the absence of any evidence for it keeps scientists awake at night. It challenges our understanding of the universe and raises profound questions about humanity's place in the cosmos. Is Earth truly unique, or are we just one of many planets harboring life? Has our species been exceptionally fortunate to be the first and only one to achieve interstellar communication? Or has something else prevented civilizations from reaching this level of advancement? The silence of the cosmos in response to our radio signals and the lack of physical evidence for extraterrestrial life leave us with more questions than answers. Is the universe truly teeming with life, or are we alone in this vast expanse? Until we make contact with an extraterrestrial civilization or discover definitive proof of life elsewhere, the Fermi Paradox will continue to elude us. It serves as a reminder of how much we do not know and the endless mysteries that lie beyond our planet. Number 2. The Grandfather Paradox. Imagine traveling back in time and killing your grandfather before your father was born. This seemingly simple action creates a time travel paradox that challenges the very fabric of cause and effect. If you were to eliminate your grandfather, it would prevent your father's existence, which in turn would mean that you would never have been born. Yet here you are, standing in your time machine about to commit this paradoxical act. This seemingly impossible scenario, often referred to as the Grandfather Paradox, poses a significant challenge to our understanding of time travel and the nature of reality. It highlights the logical inconsistencies that arise when we attempt to alter events in the past. How can something be both impossible and yet necessary for your existence? This paradox delves into the depths of our perception of time and raises fundamental questions about the nature of cause and effect. Can we truly change the past without creating unforeseen consequences? What are the boundaries of time travel, and how do they shape the boundaries of our existence? Resolving the Grandfather Paradox requires grappling with concepts such as alternate timelines, parallel universes, and the butterfly effect. Each offers a different perspective on how time might work, but none provide a definitive answer. Some argue that killing your grandfather creates an alternate timeline in which you cease to exist, while others suggest that it opens a portal to a parallel universe where the alteration in the past has no impact on your present. The butterfly effect, on the other hand, suggests that even the smallest change in the past can have massive and unpredictable consequences, potentially altering the future in ways that cannot be foreseen. These theories, while fascinating, only serve to deepen the mystery and highlight the complexities of time travel. The Grandfather Paradox remains an enduring puzzle, keeping scientists and philosophers awake at night, as they strive to unravel the intricacies of time and the implications of altering its course. Number 1. The Information Paradox. The information paradox is a mind-bending concept that arises when we try to reconcile quantum mechanics with general relativity. At the heart of this paradox lies a seemingly unanswerable question: What happens to the information that falls into a black hole? Black holes, with their immense gravity and event horizon, pose a unique challenge to our understanding of physics. Once information crosses the event horizon, it is theoretically impossible for it to escape, leading to a loss of information that contradicts the fundamental principles of quantum mechanics. This paradox challenges the very foundations of our knowledge about the universe and raises profound questions about the nature of reality. How can information be destroyed when it should be conserved? Does the information paradox suggest that our current theories are incomplete, or that the universe operates on principles we have yet to comprehend? The implications of this paradox are far-reaching, touching upon the foundations of physics, the nature of reality, and the limits of human knowledge. It keeps scientists awake at night as they grapple with reconciling seemingly contradictory concepts and searching for a deeper understanding of the universe. One way to think about this paradox is to imagine that a book is thrown into a black hole. The information contained in the book, such as the arrangement of letters, words, and sentences, represents a complex state that can be described by quantum mechanics. However, once the book crosses the event horizon, it is forever lost to the singularity, seemingly destroying the information it carries. This apparent loss of information violates the principles of quantum mechanics, which states that information cannot be destroyed. To resolve this paradox, some theories propose that information is stored on the surface of the black hole in what is known as a black hole firewall. However, this idea contradicts Einstein's theory of general relativity, which suggests that nothing can escape the grasp of a black hole. This conflict between quantum mechanics and general relativity highlights the limitations of our current understanding and the need for a more comprehensive theory of physics. 0. Schrödinger's cat. Schrödinger's cat is a thought experiment that illustrates the seemingly paradoxical nature of quantum mechanics. Proposed by Austrian physicist Erwin Schrödinger in 1935, this famous experiment involves a cat, a box, and a device that has a 50% chance of releasing a poison. According to quantum mechanics, the cat's fate is inherently uncertain until the box is opened and observed. Before observation, the cat is in a superposition of states, both alive and dead simultaneously. This apparent contradiction between the mathematical predictions of quantum mechanics and our everyday experience with classical objects puzzled scientists. How can a cat be in two states at once? What does this say about the nature of observation and the role of consciousness in the physical world? Schrödinger's cat continues to captivate and intrigue scientists today, prompting ongoing debates about the interpretation of quantum mechanics and the nature of reality. It serves as a reminder of the counterintuitive and enigmatic aspects of the quantum world and the challenges we face in understanding it. Imagine a cat placed inside a box along with a device that has a 50% chance of releasing poison. If the device activates, the cat dies, otherwise it lives. Now, according to quantum mechanics, the cat state is a superposition of being both alive and dead until the moment we open the box and observe the cat. At that point, the wave function collapses, and we find the cat in one of those states. But if the cat is truly dead, why isn't it immediately and visibly so? Shouldn't decomposition begin right away, rather than waiting until we look inside the box? This apparent contradiction between the mathematical prediction of quantum mechanics and our everyday experience with classical objects has puzzled scientists since Schrödinger first proposed it, challenges our understanding of the physical world, and raises fundamental questions about the role of observation and the nature of reality. How can an object exist in multiple states at once? What causes the wave function to collapse upon observation? And what does it mean for something to be dead before we choose to look for it? These questions remain at the forefront of scientific inquiry, driving research and debate at the cutting edge of quantum mechanics. Schrödinger's cat, though a seemingly simple thought experiment, has profound implications for our understanding of the universe and the mysteries that lie within. We hope you enjoyed this exploration of the paradoxes that keep scientists awake at night. If you found this topic intriguing, we invite you to share your thoughts in the comments section below. Which paradox puzzled you the most, and what other cosmic mysteries do you want us to uncover in future videos? Your engagement helps us create more captivating science content for you. And if you'd like to continue exploring the wonders of the universe with us, don't forget to subscribe for more updates. Stay curious and keep asking questions, because together we can unravel the secrets of the cosmos.